Welcome to the Lightning Rod channel. Don't forget to like, subscribe, and hit the notification bell for more videos. Do you know that NASA finally achieved one of their biggest milestones to protect humanity? On Monday, after 10 months in space, NASA's Double Asteroid Redirection Test, or DART, successfully hit its asteroid target, marking the agency's first attempt to relocate an asteroid in space. Bill Nelson, NASA's administrator, praised the DART team, saying the global group of scientists' work will help in the defense of Earth from asteroids. Today, we'll be discussing the great efforts of NASA's team to save humanity from future asteroid impacts. NASA usually takes great care with its spacecraft. However, things are different with DART this time around. Now, scientists have purposely crashed their ship with a spinning space rock. However, despite this crash, the mission was actually a success. Let's dive deeper into this. This mission was only a trial run to see if an asteroid can be diverted off track, a technique that may be used to deflect a near-Earth object that's headed in our direction if it's detected in time. Dimorphos is the name of the specific test asteroid, and it's located around 6.8 million kilometers away from Earth. It's really the smallest member of an asteroid pair. It's a moon of its larger brother Didymos. DART is a tiny spacecraft, approximately the size of a vending machine, yet it was traveling at an incredible 14,000 miles per hour when it crashed onto Dimorphos. The DART crew, watching from mission control, greeted each milestone as the spacecraft flew closer and closer to its destination with cheers and enthusiasm. At first, it was just a bunch of pixels, but as we zoomed in, we started to make out Didymos' outline, shading, and texture. The scene is accurate with Dimorphos. "This is so cool," said Lori Glaze, NASA's Planetary Science Division Director, 2 minutes before impact. Didymos, as seen in the craft's final camera images, is a somewhat egg-shaped rock that's scattered with rocks and craters. The images expanded rapidly in size, and suddenly, the screen went black. Broken connection. That proved the spacecraft had really collided, prompting the researchers to scream and shout. NASA's researchers think the asteroid was damaged, but didn't completely shatter, and they speculate that its orbit around Didymos may have been somewhat shortened as a result of the hit. If confirmed, this would show that the path of an asteroid may be altered by a collision with a probe. The DART team will be able to determine how effectively the strategy worked when astronomers continue their monitoring of the asteroid pair in the following weeks. NASA Administrator Bill Nelson praised the crew shortly after the disaster, stating, "We're showing that planetary defense is a global endeavor, and it's very possible to save our planet." Dimorphos is rather modest in size, stretching about 525 feet. This is around the height of the Great Pyramid. Although it posed no danger to Earth, there are likely many more asteroids and comets of a comparable size in orbits closer than the asteroid belt that have yet to be identified by NASA and its allies. Humanity probably would get in the way of the dinosaurs if a larger space object were to hit Earth. NASA has identified and monitored nearly all of the truly big near-Earth objects since 2005, when Congress gave the agency the important mission to identify asteroids bigger than 460 feet in diameter. Tom Statler, a program scientist at NASA's Planetary Defense Coordination Office, estimates that NASA and its partners have discovered only around 40% of the asteroids smaller than that. If one of those were to strike the Earth, it would cause widespread destruction, maybe even destroying an entire country or even the planet. This is the first time we've actually attempted to move something in our solar system with the intent of preventing a potential natural disaster that's been part of our planet's history from the beginning, says Statler. Since 2015, scientists have been planning the DART program, which stands for the Double Asteroid Redirection Test. It was developed, constructed, and is now being managed by the Applied Physics Laboratory at Johns Hopkins University with assistance from other NASA facilities. It was launched in November of 2016. The Asteroid Impact and Deflection Assessment (AIDA), a joint project between NASA and the European Space Agency, relies heavily on DART. Astronomers at observatories in Arizona, New Mexico, Chile, and elsewhere are keeping their scopes trained on Dimorphos and Didymos so that they may get the most accurate readings possible of the deflection after the impact. A few days prior to impact, Nancy Chabot, a planetary scientist at Johns Hopkins University and DART's coordination lead, said in an interview, Because you're coming in so fast, it's only within the last few minutes that we'll get to see what Dimorphos looks like. What's the shape of this asteroid we've never seen before? It's only within the last 30 seconds that we'll resolve surface features on the asteroid. Up until now, scientists had no idea if the asteroid would be more like a billiard ball or a dust ball. Is this moon a single giant rock, or is it a collection of pebbles or particles? We don't know. Carolyn Ernst, a Draco Instruments scientist and Johns Hopkins University researcher, stated before the hit. What scientists hope to learn from this collision depends on a variety of factors, including the composition of the asteroid, whether or not an impact crater will form, whether or not the asteroid will rotate, and whether or not it'll release rock fragments. DART, in contrast to other space missions, didn't slow down before arriving at its destination. The Deep Sleep Network, a worldwide system of antennas run by NASA's Jet Propulsion Laboratory, received a continuous stream of photographs taken by its camera as the asteroid got larger in the frame as it approached Earth. Not only are those photographs useful for research, they're also essential for navigation. Either the human operators or the probe itself needs 38 seconds to send a signal to DART or return a picture to Earth. For time-sensitive missions, the probe has to fly itself. Within the past 20 minutes, the spacecraft's automatic smart nav system acquired a precise lock on the target using these photographs, and it's been using those images to smooth its path using thruster engines ever since. In spite of the fact that the DART spacecraft was destroyed by its collision with the asteroid, the mission is only getting started. It'll take months, if not years, to analyze the data the spacecraft transmitted back and determine its impact. Ernst, however, points out that there's one piece of information that they won't receive from the spacecraft. We can't image the crater because we're the crater. In order to accurately measure DART's deflection, scientists will need Dimorphos' unique orbit around its more massive partner. Most asteroids orbit the Sun in a simple circular path, thus, any change in their orbit may take years to become apparent. However, the DART impact only affected Dimorphos' orbit around its companion and not the asteroid's orbit around the Sun. Since Dimorphos' orbit around its neighbor takes 11 hours and 55 minutes, scientists may only need a few weeks to monitor many orbits and estimate the change, which may be as little as a few minutes, for example. Chabot compares it to owning a watch that's slightly off, saying that after a week, you'll realize that you're a bit off time. In addition to these ground-based telescope observations and Draco's photographs, Chabot and her colleagues are eagerly awaiting the arrival of pictures from LICIACube, a briefcase-sized spacecraft from the Italian Orbit Agency that was sent into space by DART 15 days ago. Although a cloud of dust and rock fragments would cover the photograph, the spacecraft went past the asteroid 3 minutes after the collision in an attempt to provide after images of the crash scene. Images captured by the LICIACube are currently being stored in orbit and will be sent down to Earth in the next few days and weeks, according to Chabot. This is why the European Space Agency's Hera mission, set to launch in October of 2024, will be a part of the ADA partnership. It will meet with the asteroid pair in late 2026. The spacecraft will investigate the crash site of DART using ground-penetrating radar and other sensors to determine the asteroid's mass, composition, interior structure following the impact, and crater form. Since the DART method relies on a collision with a probe to move an asteroid, it can only be used if scientists have advanced notice that a potentially hazardous asteroid or a comet is on its way to Earth. For the scientists to be able to position the probe to meet the space rock before it's too near to be deflected with a modest push, they would need to know about a decade in advance. It won't be like the movie Don't Look Up, when the sole warning time was for a period of 6 months. Recent surveys of public sentiment have showed that the majority of Americans place planetary defense and climate science higher on their list of priorities for the United States space program than crewed missions to the Moon and Mars. This finding is consistent with previous findings. It's logical given the potential dangers posed by near-Earth asteroids and climate change to all human life on Earth, and it's why scientists have to risk trying out experiments like the DART mission. DART is really the first demonstration of a technique we might use to defend the planet, Ernst says. You can theorize, you can run laboratory experiments at small scales. However, this information is crucial for us to comprehend what we may do if we were to encounter a threat.